component like resistor, capacitor, diode, transistor, fuse with the multimeter. If you not yet subscribed the channel, please do subscribe and share your feedback in the comment section. It will definitely encourage me to make more such useful content. Now let's get started. Now in this video I am going to measure all these electronics component with the help of this multimeter. As you can see, this is not a auto select multimeter. I have to select the range accordingly, but I will also explain how to measure with the auto select multimeter. Now before measurement I have to connect these two lead with the multimeter. So first I am going to connect this black lead in the common port of the multimeter. Next I am going to connect the red lead with the voltage and ohm port. As you can see, the symbol of ohm and the V is written here. As I am going to measure the resistance voltage first, so I am connecting the red lead in the voltage and ohm port. If I have to measure the current, then I have to use these two port. So I am connecting the lead in the voltage and ohm port. Now I am turning on the multimeter. First I will measure the DC voltage of a battery. As you can see, this is a 9-volt battery. I am going to measure the voltage of the battery with the help of this multimeter. So I have to select the voltage scale. V indicate the voltage. As this is a 9-volt battery, so I am selecting the 20-volt scale. Next I have to connect the red lead in the positive terminal of the battery and black lead with the negative terminal of the battery, and it's showing reading 9.4 volt. So we can easily measure the voltage of the battery, which is a DC voltage, with the help of this multimeter. Next I am going to measure the resistance with the help of this multimeter. For that I have to select the ohm scale. As you can see, this is a symbol of ohm, so I have selected the ohm scale. From the color code I can easily calculate the nominal value of the resistance. Now the nominal value of this resistance is 1 kilo ohm. So I have to select the range accordingly. I have selected 2K. So I will see the reading in kilo ohm scale here. So I can easily measure the resistance by connecting two lead of the multimeter with the two terminal of the resistor, and the reading is in kilo ohm scale, which is 0.98 kilo ohm. So we can easily measure the resistance, but if the resistance value is very low or very high, we have to keep some point in mind before measuring the resistance with the help of this multimeter to get accurate result. Now this is a 1 ohm resistor and this is a 1 mega ohm resistor. First I will show you how to measure accurately 1 ohm with the help of this multimeter. Now again, from the color band I can say the nominal value is 1 ohm. First I have to select the range. Now I have selected the lowest scale, which is 200 ohm. Now the reading will show in ohm. Next I have to measure the resistance like this, and it's showing 1.3. Now what I have to do, I have to connect these two lead to measure the lead resistance, and it's showing 0.3 ohm. Previously we got the result 1.3. Now the lead resistance is 0.3. If I subtract 0.3 from 1.3, we will get accurately 1 ohm, which is the nominal value of this resistance. Thus we can accurately measure the lower value resistance. Now as I have said, this is a 1 mega ohm resistor, and from the color band I can easily calculate the nominal value, which is 1 mega ohm. Now again I have to select the scale. I have selected 2000K, which is 2 mega ohm. So again the reading will show in kilo ohm scale. Now I have to connect the two lead like this to get accurate result. Now you can see the reading is approx 1000 kilo ohm, which is 1 mega ohm, which is also a nominal value of this resistance. But if I hold the resistance like this, then you can see we are getting erroneous result, which is 600 kilo ohm. So if I hold the resistance like this during measurement, what I am doing, I am connecting my body across the resistor, so it will give me a erroneous result. For measuring the higher value of resistance, I have to hold the resistance like this. I have to hold the resistor with one hand and I have to connect the lead on the other terminal like this, and we are getting again the accurate result, which is 1000 kilo ohm or 1 mega ohm. So we have seen how to measure the resistor with the help of this multimeter. Next I am going to measure the capacitance of this capacitor. As you can see, this is a electrolytic capacitor and it is a 10 microfarad capacitor. As you can see, it's written on the body. Now I can measure with the help of this multimeter up to 20 microfarad, and the nominal value of this capacitor is 10 microfarad. So I can measure this capacitance with the help of this multimeter. Now to measure the capacitance, I have to select the farad scale. Farad is a unit of capacitance. As I am going to measure the 10 microfarad capacitor, so I have selected the 20 microfarad scale. Now before measuring, it is very important to discharge the capacitor. For discharging, I am connecting a metal screwdriver across the lead. Then I can insert this capacitor into this slot to get the reading. Now you can see it's showing the reading in microfarad scale, as I have selected 20 microfarad, and the reading is 9.19. So as the nominal value of the capacitor is 10 microfarad and from the reading I am getting 9.1, so this capacitor is okay. 20% deviation is possible for measuring a capacitor. Next I can also measure this capacitor. Again, the nominal value of this capacitor, as you can see, is 0.47 microfarad. So again I have to select the range accordingly. I have selected 2 microfarad to get precise result, and again I have to discharge it in same manner. Now I can insert into this slot to get the result, and it's showing 0.46 microfarad as I have selected 2 microfarad. So the nominal value is 4.7 and it's showing 0.46. So this capacitor is okay. Thus we can measure the capacitance with the help of this multimeter if we have farad scale present in the multimeter. But if you want to measure any higher voltage capacitor, like this is a 160 volt capacitor, so for discharge I will suggest to use a resistor and connect the resistor with the two terminal of the capacitor like this for discharging it. After that you can measure. As the capacitance value of this capacitor is very small and the voltage is also small, so I have just connected a screwdriver to discharge it. In my previous video I have already shown how to test different type of capacitor with the different method, with and without a multimeter. So please go and check the video. I have given the link in the description. Next we are going to measure the diode with the help of this multimeter. So as you can see, this is a symbol of the diode. First I have to select this symbol. Next, as you can see, this is a diode and this is a band. With the help of this band I can easily say this is anode and this is cathode if the band is here. So for testing I have to connect the red lead with the anode and I have to connect the black lead with the cathode, and the band is here. As you can see, we are getting a reading 0.5. Next I have to connect the black lead with the anode and the red lead with the cathode, then we will get over limit. As current can flow through a diode only in one direction, so if this positively biased, then we can get the reading. Now in this condition I have connected the black lead with the anode and red lead with the cathode, so this is negatively biased, so we will get no reading as no current flowing through the diode. This diode is okay as we are getting reading only connecting the red lead with the anode and black lead with the cathode. Again we are going to test this diode. You can see this is a band, and again I am connecting the red lead with the anode and black lead with the cathode, and we are getting some reading in the multimeter as the diode is positively biased. And if I reverse the terminal, black lead to anode and red lead to cathode, again we are getting reading. So it's indicate this diode is not okay, as current can flow through this diode in both direction, as we are getting result in both case. So thus we can easily check whether a diode is good or bad. Now with the same method we can easily identify whether a LED is good or bad. Now there are two terminal, anode and cathode. To identify anode, we have to see which one is longer lead of the LED. The longer lead is anode and the shorter lead is cathode, negative terminal. And another way to identify anode and cathode of the LED, we have to find a flat surface here. This is a flat surface, as you can see, and the terminal near to flat surface is cathode. So this is cathode, this is anode. Now to check whether the LED is good or bad, we have to connect the red lead with the anode, which is a longer terminal, and a black lead with the cathode, and we'll get reading 1.5, which is a forward voltage of the LED, and you can see the LED is glowing after connecting anode with the red lead and cathode with the black lead. So this LED is okay. If the LED will not glow after connection, then this LED is bad. Now we can also check a transistor whether it is NPN or PNP, or the transistor is good or bad. Now I am going to test the transistor with the help of this multimeter. You can see there are three terminals for a transistor. First I am going to connect the red lead in between, as you can see. Next I have to connect the black lead with these two terminals of the transistor. If I get reading, then the transistor is NPN. As I am not getting any reading after connecting the middle terminal with the red lead and black lead with the another two side terminal of the transistor, so this transistor is PNP. Middle terminal is N. If I connect the black lead with the middle terminal for the same transistor, and if I connect the red lead with the two side terminal, I will get the reading in both cases. You can see 0.6, and here you can see 0.6. So this is PNP transistor. If I connect the black lead with the middle terminal, then I will get no reading for a NPN transistor. If I connect the black lead, you can see in the middle, and I am connecting the red lead with the two side terminal, I am getting no reading for NPN transistor. If this is PNP, then I should get reading in this. Like we can easily identify whether this is NPN or PNP. Next, if I get result by connecting two side terminal in the multimeter, then the transistor is not okay. You can see, as I am getting result by connecting two side terminal, then it's indicate the transistor is damaged. But for a good transistor, I will get no reading. If I connect the two lead of the multimeter with the two side terminal of the transistor, if I alternate the lead, again I am getting no reading for a good transistor. Thus we can easily check whether the transistor is good or bad, whether it is NPN or PNP. Lastly, we'll check the continuity function of the multimeter. As you can see, for a diode transistor we have selected this diode symbol. Now we'll select this continuity symbol. This is a continuity symbol, as you can see in the screen. To check fuse, relay coil, transformer coil, this function is very helpful. Now first I am going to check the fuse. with the help of this multimeter. As you can see, I am connecting the two lead with the two terminal of the fuse, and I am getting a beep sound and it's showing 0.3. So with the help of this beep sound is indicate this fuse is okay. Now I am going to measure this fuse also. Again I am connecting the two lead with the two terminal and I am getting no beep sound. So this fuse is blown out. Thus you can easily check whether the fuse is okay or blown out. If you find this video helpful, please hit the like button and share it with your friends. Don't forget to subscribe our channel for more such videos, and definitely share your feedback in the comment section. Thank you for watching. Have a great day.